Welcome to session 7 of Introduction to Computing course Csit 103. And in this course, we will discuss algorithms. Computers do what we tell them to do and not what we want them to do. There must be no ambiguity in the instruction that is given to a computer, else you get garbage out. However, many programs appear to be compressed from a programming point of view. Therefore, it is necessary that we are able to express programming problems in a simple, unambiguous manner, following some order. In this session, we will discuss algorithms, flowcharts, and pseudocodes. This outline will give us introduction of algorithm, narrative description of algorithms, flowcharting in algorithms, algorithm language, which is pseudocodes, and then the program execution. Reading list is on the Sakai. In algorithms, what is an algorithm? An ordered sequence of precise steps that describe the solution of a given problem. This is what we say it is information processing or computations. Step-by-step procedure to solve a problem. Important properties of algorithms. Simple, unambiguous, and following a prescribed order. Effective in solving a problem is a finite number of steps. In short, it is just a list of steps to describe a task, how a computer should to solve a certain problem. An algorithm has a start point and a stop point. So in designing algorithm, you start from somewhere and you end at a point. The stop may provide some output. An algorithm is made of individual instructions. Each instruction is well defined and its outcome predictable if the instruction operates on valid input. So at each level of algorithm in a list, something must happen to the task in question. There is a direction of logic flow or sequencing. Once an instruction is executed, control is passed to another instruction. When executed within valid input, an algorithm is guaranteed to terminate. Why algorithms? Because we need efficiency. Problems that occur often in computing require some algorithm to solve and optimize time and cost. This we term as efficiency. Algorithms help decompose seemingly complicated problems into simpler ones. In short, we call abstraction. An efficient means of solving simpler problems allows for solving complicated problems. So algorithms are reusable. Problem solving. It involves the following. You determine what the output should be. In solving a problem, you first determine what the output should be. You identify the input data necessary to obtain the output, and then you determine how to process the input to process the desired output. So in computing, we simply have this simple diagram: input, processing, and output. Development of the procedure itself helps to identify processes, major decision points, and variables necessary to solve the problem. Then identification of the processes and decision points reduces the task into a series of smaller steps of more manageable sizes. Decision making becomes a major rational process. It makes a process more efficient and consistent. Benefits of an algorithm. Efficiency due to the analysis and specification processes. Consistent comes from both the use of the same specified process and increased skill in applying the process. An algorithm. Improvement in problem solving. The existence of a specified solution process allows identification of weaknesses and errors in the process. Expressing algorithm. Algorithm could be expressed using narrative description stroke natural language, flowchart, pseudocode, structured ways of expressing algorithms. It overcomes the issues of ambiguity in natural language statements. It is independent of a particular implementation language. Expressing algorithm. We use programming languages to express algorithm in the form that can be executed by a computer, often used to define or document algorithms. Working case. Assuming we have a student final grade in a course is computed as the average of 4 marks received on tests throughout the year. Write an algorithm to determine a student final grade and indicate whether it is a passing or failing grade. Pass grade is 50. This is a question or a programmable question. So to provide an algorithm for this question, you first have to, all you have to do is outline the steps verbally using natural language. Example, as we see in recipes, recipe for food. Tends to be verbose and ambiguous, rarely used for complex or technical algorithms. So issues. Use of natural languages is wordy, imprecise, and unreliable. Comprehensibility is sacrifice and precision. Misinterpretation and or information loss based on the one language, how you present one language to the other. So in working or solving the problem, first you read a set of 4 marks. Then compute their average by summing them and dividing by 4. If this average is below 50, display the grade with a failing message. Otherwise, display the grade with a passing message. So this simply explains or analyzes the problem at hand. Flowchart. Flowchart has been used in computing for quite some time in the field. Flowcharting is good. It is a pictorial representation of the algorithm. A pictorial format for showing the logical steps involved in a process, showing how each step relates to the other. It shows the logic of an algorithm. It emphasizes individual steps and their interconnections. It combines symbols and flow lines to show the operation of an algorithm. Generally drawn in the early stages of formulating computer solutions, facilitates communication between programmers and business people, helps in understanding the logic of complicated and lengthy problems. It makes it easy to write the program in any high-level language. So in flowcharting, we make use of symbols. We have this symbol, arrow symbol, which dictates the flow line. We also have this symbol, which is the terminal, the starting and the terminal. This oval is used to start a flowchart and ends a flowchart. The input-output symbol, the processing symbol is this rectangular box, and the decision box is also here. The connectors, when you want to connect one flowchart or to another page, used to join different flow lines, is the connector. We have the off-page connector. That is when you are moving from one page to the other on the same flowchart, you use this symbol to connect it. Then the predefined process symbol, the annotation symbol. All boxes are connected with arrows in flowcharting, not lines. Symbols have only one entry point on the top of the symbol with no other entry points. The exit point for all flowchart symbols is on the bottom except for the decision symbol. The decision symbol has 2 exit points. It can be on the sides or the bottom and the one side. All necessary requirements should be listed out in logical order. All boxes are connected with arrows. not lines. Symbols have only one entry point on the top of the symbol with no other entry points. The flowchart should be neat, clear, and easy to follow. The flowchart is to be read left to right or top to bottom. Flow lines. A process symbol can have only one flow line coming out of it. A decision symbol can have only one flow line entering it, but multiple lines can leave it to denote possible answers. The terminal symbols can only have one flow line. This is a decision symbol. It has more than one line outlet, but you enter in a decision with one line or one entry. If condition is true, process A, S, process B, this is what depicts a decision symbol. Y condition is true, process A, and Y. So this is also another kind of decision you can get. So flowchart is in the problem we gave you to find the average of 4 text marks. We start and we input, this symbol is an input symbol. So we input the 4 marks, M1, M2, M3, and F4. And then we find the grade by dividing in the processing symbol, we divide the total of the marks by 4. And then we store the value in grade. So we come and test the grade. Is grade less than 50? If yes, we say congratulations. If yes, if grade is less than 50, you have failed. So you pass with a grade, but you fail the pass mark. If the grade is greater than 50, we move here, this direction, where we say congratulations, you've passed with a grade, and then it all ends after, whichever path this decision takes, it brings you to the end here to stop. You can also display your outputs in here. Benefits of flowchart. It helps the communication in algorithms, provides better way of communicating the logic of a system to all concerned. It is effective analysis. It helps in analyzing the problem in more effective manner. It is good for proper documentation. It serves as a good program documentation, which is needed for various purposes. Anybody can read through a flowchart. It helps in efficient coding. It acts as a guide or blueprint during the system analysis and program development phase. It also serves as proper debugging. It helps in the debugging process. Efficient program maintenance helps make the maintenance of an operating program easier. Even if you are not the one who developed the program, you can use the flowchart of a program to maintain it. Flowchart limitation. Complex logic. When the program logic is quite complicated, flowchart becomes compressed and clumsy. Alterations and modifications. If alterations are required, the flowchart may require redrawing completely. Reproduction. Flowchart symbols cannot be typed, hence its reproduction becomes a problem. The essential of what is done can easily be lost in the technical details of how it is done. So we come to the next one is pseudocodes. Pseudocode is another algorithmic language. In algorithms, you can express them in flowchart, you can also express them in pseudocodes. Pseudocodes is a generic way of describing an algorithm without use of any specific programming language or syntax. It is also, you specify the steps required to accomplish the task. An informal high-level description of the operating principle of a computer program. It uses structured English. It cannot be compiled nor executed because it is not a syntax. It is not in any programming language format. There are no rare formatting or syntax rules. You can write it any way but symbolic. It cannot be executed or on a rare computer. However, it models rare programming code. It uses the structural conventions of a programming language. It's also written at almost the same level of detail. It is intended for human reading rather than machine reading. Steps are numbered. Subordinate numbers or indentation are used for dependent statements in selection and repetition structures. Advantages of pseudocode: reduce complexity, increase flexibility, ease of understanding. Pseudocode statements indicate how basic computer operation is performed for a given problem. Basic computer operations include accepting data, read information from a file, get information from the keyboard, produce output, which means write information to a file, display information to the screen. Perform arithmetic computation. Actual mathematical symbols or the words for the symbols are used. Example, add number to total. Total equals to total plus number. Addition, sign, subtraction, multiplication, and division. Words like calculate, compute are also used. Comparison in order to select one or two alternative actions. If condition, then perform some action. Else, perform some alternate action. And if. Repeating a group of actions. While condition is true, perform some action. Goes through until the while condition is true. For a number of items, perform some action. And for. So the for and the while are conditional statements used in this case. Pseudocode guidelines. Write only one statement per line. Capitalize initial keyword. Example, read, write, if, else, and if, why, and why, repeat until, etc. Indents to show hierarchy. And multi-line structures. Example, and if, end loop, else, and others. Keep statements language independent. Pseudocode language construct. Computation / assignment. Compute variable 1 as the sum of s and y. Assign expression to variable 2. Increment counter. Input output. Input. Get variable 1 to read variable 1 to output. Display variable 1, variable 2. Write variable 1, variable 2. Selection. Single selection if. That is simple if. If, else, if without else. Double selection if. If and then else. Repetition. While loop. Do while loop. For loop. These are all structures in using to design algorithms, and they can be written in pseudocodes. Do while test condition at the end of the loop. Hence, statements in the structure will be executed at least once. Use of variables. Variables are used in programming a lot. So in pseudocodes, they are used. Variables are termed as symbolic name for memory location in which data can be stored and subsequently recalled. It acts as placeholders for holding data values for various computations in a program. They be consistent in the use of names in a program. Contain no spaces. Pseudocode solution to working case. Now, as we seen, we presented the working case in flowchart. If we want to present this same case in the pseudocode mode, what we do is we read 4 marks and put them in variables M1, M2, M3, and M4. Then we say grade, which is the output field, is equals to M1, M2 plus M3 plus M4. We total the marks, then divide by 4. if now we have a value in grade, which is the output or the average mark. So if the grade is less than or equals to 50, then we write or display, sorry, you fail with grade of grade. Then else we say, write, congratulations, you passed with a grade of grade. So this is a typical pseudocode for the working case given to us. Then halt means stop, which the computer will stop. Example 1. We have condition box with true or false. So if the condition in this decision box is true, the flow line will take the true line. If it's false, it will take the false line. So whichever line it takes depends on the condition in the decision box as here. If it's true, task A will be performed. If it's false, task B will be performed. If condition is true, then do task A, else do task B. So this is the pseudocode for this diagram as you see here. Example 2. Write an algorithm to determine a student's average grade and indicate whether he is successful or not. The average grade is calculated as the average of midterm and final marks. Student will be successful if his average grade is greater or equal to 60. So this is another working case. How do we put it in pseudocode? We first say start, then use variables to represent midterm, final, and average. So these are storage locations in memory. Then we do inputs, which we input data into this memory of midterm and final. Then midterm value and then final value. They will all be stored here. Then calculate the average by summing midterm and final average, dividing by 2. So when we add the midterm value and the final exams value, we divide by 2, then we have calculated the average. Then we now going to test whether you have passed or failed. If average is below 60, we say you have failed. That is the pass mark, so you failed. Else we display success, congratulations, you have passed. And then we say end if to end the if statement, and then stop to end the entire process. Detailed algorithm. Input midterm and final. Average equals to midterm plus final. If average is less than 60, then display failed, display success. So this is a typical algorithm we have shown earlier. So flowchart advantages and pseudocodes. Advantages of flowchart: standardized, visual. Disadvantage: how to modify, structured design elements, not implemented, special software required. In pseudocode, advantages are easily modified, implements structured concepts, done easily on word processor. Advantage is not visual, nor accepted standard, varies from company to company. We move on to program execution. Computer instructions are copied from memory into CPU when necessary. Computer instructions that perform a certain task, which we term as a program, is always stored in a memory. Then during processing, these instructions and data will be moved from the memory into the CPU registers, where the processing can take place. The computer tends to follow these instructions. Instructions in the CPU are decoded and obeyed. The order in which the instructions are fetched from memory corresponds to the order in which the instructions are stored in memory, unless otherwise altered by a jump instruction. Program execution. Instruction register used to hold the instruction being executed. Program counter. It contains the address of the next instruction to be executed. So these are registered, special purpose registers, which we saw earlier in the lesson 1, where which is always utilized here in any processing activity. It contains the program counter contains the address of the next instruction to be executed. Then it helps the machine to keep track of where it is in the program. The CPU continually repeats an algorithm that guides it through a three-step process known as machine cycle. The three steps are fetch, decode, and execute. In any processing activity in the computer's CPU, there is this three step that takes place: fetch, decode, and execute. The fetch, actually CPU places a request, and the fetch process retrieves the contents of memory cells. So the fetch is where data and instructions are moved from memory into the registers in the CPU. And the CPU places the instruction received from memory in the instruction register. Then the CPU finally increments the program counter. This prepares the program counter for the next fetch. Then in the decode step, instructions is now in the instruction register. So CPU decodes the instructions. It involves breaking the operand fields into its proper components based on the instruction operand's code. Execute step. The CPU activates the appropriate circuitry to perform the requested task. So this is a typical machine cycle where fetch, decode, and execute takes place. This is the cycle demonstrated. Then we have your reference, An Introduction to Computer Science.